Okay, this is the P1 paper from October 2023. It's question number 8, and this is a question from chapter 3, equations and inequalities. We're going to be solving simultaneous equations with this one. So let's have a look at it. It says we've got curve C1 with this equation here, curve C2 with a different equation, and it says show where the two equations meet. So the two equations will meet as we solve the simultaneous equation, or where y is equal to y. That's what I'm going to do with my working out. So for C1, part A, for C1, I'm just going to rearrange the equation to get y equals. So we had xy is equal to 15 over 2 minus 5x. And so y is going to be equal to, I'm just going to divide everything by x here. So we get 15 over 2x minus 5 here. And then what I can say is that this y here is going to equal this y up here. Let's tell the examiner I'm doing that. So curves meet when 15 over 2x minus 5 is going to be equal to what we had up there, which is x cubed minus 7 over 2x minus 5. I'll do a little bit of work here, but I'm assuming it's going to get to that quartic equation that we had. So what can I do here? I can get rid of the 5s straight away. So I'm going to get 15 over 2x is equal to x cubed minus 7 over 2x, like that. Let's just multiply everything by x. So I'm going to get 15 over 2 is equal to x to the 4 minus 7x squared over 2. Let's multiply everything by 2. So we could say here, you don't really need this, but multiply by x, multiply by 2 is going to give me 15 is 2x to the 4 minus 7x squared. And if we look, we pretty much got that. So 2x to the 4 minus 7x squared minus 15 is equal to 0. Then that's this first part done here. So then the second part says they meet at points P and Q. Use algebra to find the exact distance of P and Q. So I'll explain this. I'm not going to keep this as part of my answer, but basically we've got a curve here and a curve here, which are going to meet at 2 points. So I need to solve my equation and get those 2 points. And if they meet at PQ, once I've got the coordinates of PQ, I can just use the formula for the length of the line, square root of x2 minus x1 squared plus y2 minus y1 squared, which you should be very familiar with. But basically what we're saying is we need to work out what P and Q are here, and P and Q will be the solutions to this equation. So if I've got 2x to the 4 minus 7x squared minus 15 equals 0, and every time I ask my students in my class what sort of equation I've got on the board, they know automatically it's going to be a quadratic of some sort. So this is one of the variations of a quadratic that we can have if we let u equal to x squared. Then suddenly I get 2u squared minus 7u minus 15. So now I've got a quadratic which I should be able to solve. I'm expecting this to be able to factorize at this level of going through an equation here. I'm not going to do the factorization. Go back and look at other videos that I've got on the channel to show you how to do this. If you can't, would be a worry at this stage if you don't know how to differentiate something like this pretty quickly. To factorize, something like this pretty quickly. So we're going to get 2u plus 3 equals 0, which is going to give me u equals minus 3 over 2. We're going to have u minus 5 equals 0, which gives me u equals 5. So then what it means is that I have x squared equals minus 3 over 2. And I'm really delighted to have got that because that's going to give me no solutions, which means that the other one, x squared equals 5, x equals plus or minus root 5. I wanted to get 2 solutions and the 2 values for P and Q here, and they're going to come from that. So x is equal to root 5 and minus root 5. y, let's go back and use, I'm going to use 15 over 2x minus 5 as my way of finding out what y is. So that's going to be, y is 15 over 2 root 5 minus 5, and obviously we'd have and minus 15 over 2 root 5 minus 5 as my coordinates. So P is equal to root 5, 15 over 2 root 5 minus 5, and Q is going to be very similar, minus root 5 minus 15 over 2 root 5 minus 5. I'd tidy up the denominators there if these were answers, but they're not. I'm trying to work out the length of PQ, so I can just leave those in there. As I said previously, PQ is just going to be the square root of x2 minus x1 squared, plus y2 minus y1 squared, and then just put everything in there. So I'm going to get root 5 minus minus root 5, so that's root 5 plus root 5. Over, and this is going to be longer to write out than it's going to be to do here. This is going to be plus 15 over 2 root 5 minus minus 15 over 2 root 5. So in other words, 15 over 2 root 5 plus 15 over 2 root 5 squared. Now that's actually taking longer to write out than it will be for you to just chuck all that into a calculator and see what it works out. And PQ apparently works out to be equal to, when we go through do all that, PQ works out to be equal to root 65. Let's just see. Yes, and it says, I'd ignored that up till that point, but it says find the exact value. So it needed to be a third answer and not a decimal. But yeah, not too bad as a question there. Question number 8 on a P1 paper. So hopefully that all makes sense to you.